Hi supervisors, we're Bothell High School Blue Team 27. I'm Fedora Leonto and my partner Dylan Varden is behind the camera. This is our hydrometer. You use it to approximate the percent salinity of an aqueous solution. This is assuming conditions like 1 atmosphere pressure, 20 degrees Celsius, and the salinity is between 0 and 10%. So this is our schematic and this is the actual salinometer. As you can see, there's 11 tick marks corresponding to salinity between 0 and 10% and 1% increments. The only labeled tick marks are 0, 10, and 5%, and which are the salinities we'll be testing today. So, as to how to read this thing, you gently place it in the solution and you observe where the red stick meets the water surface. For example, in this 0% solution, we expect that the water's level will align with the 0% salinity mark shown here. So, we'll test it now. As you can see, the water level is perfectly aligned with the black 0% mark on the red stick. And the same goes for the 5% solution. You also observe where the red stick meets the water surface in that solution, and it should correspond with the 5% salinity mark on here. So we expect that the water level will align with this mark over here, this 5% mark. Okay? So here's the 5% solution. And we'll drop it in carefully. So as you can see, the water level is perfectly aligned with the 5% line on the red stick. And the same goes for the 10% solution. There's a 10% mark here, and that's where, when put into 10% solution, we expect the water level to align with on this stick. Now we'll test it. So as you can see, that line, the 10% line, is perfectly aligned with the water surface at this 10% salinity. If the water level ends up between two tick marks, that indicates that the salinity of the solution is between the salinities of those two tick marks. The water level alignment is different for each salinity because solutions of higher salinities have higher density and therefore exert a higher buoyant force on the hydrometer, pushing it upwards more. This is clearly shown on this graph. For background, in this graph, the independent variable, the x-axis, is the salinity, and the dependent variable, the y-axis, is the tick's distance from the 0% mark. You can see that putting the hydrometer in a 5% solution, which is here, causes it to be pushed up about 30 millimeters more than in the 0% solution, which is just 0 because that's the same tick mark. And putting it in a 10% solution causes the hydrometer to be pushed up about 55 millimeters more compared to the 0% solution. In this graph, the calculated line of best fit is 5.4x plus 1.7. The slope is plus positive 5.4, which means that for every 1% increase in salinity, the distance from the 0% mark is expected to increase by about 5.4 millimeters. And even just looking at the graph, you can tell that the trend is linear because for every increase in salinity, the distance from the 0% mark seems to go up by a relatively constant amount. Thank you, supervisors.
Thank you, supervisors.